Okay, see, this is the question from again April 2019. Okay, from your paper of Manipal. Now, in this question, what they have said, the effective inductance when two coils are connected in series means there are two coils. Let us connect them in the series. This one would be the L1, this one would be the L2, right? Effective inductance, what they said, effective inductance means the L equivalent value they have given 10 Henry, correct? When the terminals of one coil are reversed, means if like suppose they are connected like this, then we reverse the terminal. Now the L2 is connected like this, right? Then the effective inductance is 6 Henry. So in this case, effective inductance is how much? 6 Henry. Now they said if the coefficient of coupling is 0.6, coefficient of coupling that I told you, that is K12 is how much? 0.6. We need to calculate the value of L1 and we need to calculate the value of L2, right? So as you know, if the two coils are connected like this, then in that case formula is L1 plus L2 plus 2M, right? And in this case the formula is L1 plus L2 minus 2M, correct? And that would be equal to 10 Henry and that would be equal to 6 Henry, correct? So we are having the formula for M12, that would be M12 and this is also M12, right? So tell me what was the formula for the M12? M12 is equal to K12 root of L1 into L2, right? So can I write down M12 is equal to K12 root of L1 into L2? So do we know L1 and L2? No. Do we know K12? Yes, we know K12, right? So can we substitute the value of M12 here, right? So that would be L1 plus L2 and M12 is how much? Plus 2 into K12. K12 is how much? 0.16, correct? Root of L1, L2. Similarly, we can put this in the another equation is equal to 10. Second equation will get it as L1 plus L2 plus, sorry, plus ni minus 2 into M12 is again 0.1 K12 into L1 into L2 is equal to 6. So now we'll have two variables and the two equations, right? So can we solve it? And then we'll get the value for L1 and L2. It will make a quadratic equation. If you'll solve it, then you will get two values. Got it?